Dear students, now we are going to discuss circular waveguide and derive its field components. Circular waveguide is a hollow metallic tube in circular cross section. It is mainly used for electromagnetic wave propagation. So it's widely used in microwave applications. So this is the structure of circular waveguide and field components inside the circular waveguide. Next we are going to derive the field components of the waves propagating inside the circular waveguide. In order to determine the field components within this waveguide, we have to solve Maxwell's equation with the appropriate boundary conditions. Okay, so here we are going to consider cylindrical coordinate system. Okay, cylindrical coordinates means rho, phi and z. Okay, first we have to consider the Maxwell's first equation for non-conducting medium. Okay, because the surface of the circular waveguide does not conduct, so we have to say that is a non-conducting medium. So here the Maxwell's first equation from Ampere's circuital law is given as del cross H bar is equal to j omega epsilon E bar. So this is the first equation for non-conducting medium. So here this del cross H represents curl operation. So here we can write this curl operation like this: A rho bar by rho, A phi bar, A z bar by rho. So here A rho, A phi, A z represents unit vectors. Then dou by dou rho, dou by dou phi, dou by dou z, H rho, rho H phi, H z. So this is the curl operation for this cylindrical coordinate system. That is equal to, this right hand side can be written like this: j omega epsilon E vector can be written like this: A rho bar E rho plus A phi bar E phi plus A z bar E z. Okay. Next we are going to solve the curl operation. For that we can keep this first value A rho bar by rho. For this value we have to multiply the next two columns like this. So dou hz by dou phi minus dou rho h phi. Here we can take this rho outside. So rho dou h phi by dou z. For the second column we can use minus sign. So minus A phi bar into, here we can cross multiply these two values. Okay, so dou hz by dou rho minus dou h rho by dou z. Then we can take this third value, that is A z bar by rho multiplied with the cross multiplication of these two columns. So here it is dou rho h phi by dou rho minus dou h rho by dou phi. So here also we can take this rho outside in the next step. So here the right hand side is same as such. Okay. Then we are going to equate the rho phi z components on both the sides. So here it is a rho component, here it is a phi component, here it is a z component. So we are going to equate both the sides. So first we are going to take the A rho component. Here we can take 1 by rho, its value alone, not the unit vector. Okay. So here it is 1 by rho dou hz by dou phi minus rho dou h phi by dou z is equal to, this side its value is j omega epsilon is common for all the terms. So here we can take j omega epsilon E rho. Okay. Then we have to multiply this 1 by rho inside this column. We can get dou hz by rho dou phi minus, here rho cancel. Then we can get dou h phi by dou z is equal to j omega epsilon E rho. Okay. Consider this as the first equation. Then we have to take the phi value. So here we can take this phi value as such. Here there is a minus sign. So we have to multiply this minus sign inside this bracket. We can get this value as plus, that is minus into minus plus dou h rho by dou z minus dou hz by dou rho. That's what given over here. Dou h rho by dou z minus dou hz by dou rho is equal to this side j omega epsilon E phi. Then that z component, that is nothing but 1 by rho dou h phi by dou rho minus dou h rho by dou phi is equal to j omega epsilon Ez. Then we have to multiply inside this 1 by rho. Then this term cancel and here we can get dou h phi by dou rho minus dou h rho by rho dou phi is equal to j omega epsilon Ez. consider this as the third equation. So these three equations are the basic equations. From this we can get the field components. Okay. So next, it is very important point over here. As we all know that if the wave is propagating in any direction, there is some propagation loss. Propagation loss means its amplitude is getting reduced by traveling in the direction. Okay. So here the wave is propagating in the z direction. Since it is propagating in the z direction, the amplitude of the wave is decreased by the propagation factor e power minus gamma z. So this is very important point. Gamma is nothing but propagation constant. Okay. If the wave is having the field components h rho, its amplitude is reduced by the factor e power minus gamma z. So here this h rho 0 represents the magnitude. Okay. So this is the magnitude of the wave component propagating in the z direction. If we are going to differentiate with respect to the propagating direction, then we can get h rho naught e power minus gamma z into minus gamma. Correct? We are differentiating with respect to what? Z. Okay. Then we can get minus gamma. This value is nothing but h rho itself. So here you have to remember one thing. For any field components which are propagating in the z direction, then its differentiated value is equal to minus gamma with that particular value. Similarly, we can get the values dou h phi by dou z is equal to minus gamma h phi, dou hz by dou z is equal to minus gamma hz, dou h rho by dou z is equal to minus gamma h rho. We are going to substitute these values in the first, second and third equations. Okay. So first we can consider the first equation. So in that equation, the first value is what? Dou hz by rho dou phi. What is the next value? Actually it is minus, in the first equation its value is what? Minus dou h phi by dou z. Correct? That is the value. So here this value is replaced with the value minus gamma into h phi. Correct? So then minus into minus plus gamma h phi is equal to j omega epsilon e rho. That is the updated version of the first equation. We can say it is 1.a. Similarly, we can take the second equation. In the second equation, what is the first component? Actually, it is dou h rho by dou z. So this value is replaced with the value minus gamma h rho minus dou hz by dou rho, that is equal to j omega epsilon e phi. So here we can consider this as the 2.a. Similarly, we can take the third equation, but this equation does not have any dou by dou z value. So we can keep this value as such. Okay. So these three equations are simplified version of the first three equations. Hereafter we are going to use these three equations. Okay. So we are going to consider Maxwell's second equation. So here we can take the second equation, del cross E is equal to minus j omega mu h. Actually it is a vector. Okay. So del cross E vector is equal to minus j omega mu h bar. So the same way we can take the curl operation for this electric field, a rho bar by rho, a phi bar, a z bar by rho. Dou by dou rho, dou by dou phi, dou by dou z. Here its value is e rho, rho e phi, e z is equal to minus j omega mu into, here h vector can be written like this, a rho bar h rho plus a phi bar h phi plus a z bar h z. Okay. Then we have to solve this curl operation. Okay. So whatever we have done for the first equation, the same way we have to solve this. So here we can keep the first value a rho bar by rho and cross multiply these two values. So dou e z by dou phi minus rho dou e phi by dou z. For the second column its value is minus a phi bar into dou e z by dou rho minus dou e rho by dou z plus a z bar by rho into, here we can take these two values. Okay. So here it is rho dou e phi by dou rho minus dou e rho by dou phi. That is equal to, we can have the same value as such. So next we are going to equate the rho phi and z components on both the sides. So first we can take that rho component. Here it is 1 by rho dou Ez by dou phi minus rho dou E phi by dou Ez is equal to this sign minus j omega mu h rho. Then we can multiply this 1 by rho inside this bracket. We can get dou Ez by rho dou phi minus dou E phi by dou Ez is equal to minus j omega mu h rho. Consider this as the fourth equation. The same way we can equate this phi value and then this z values. Okay. Next we have to equate the phi components on both the sides. Then we can get dou E rho by dou Ez minus dou Ez by dou rho is equal to minus j omega mu h phi. So consider this as the fifth equation. Then Z component 1 by rho into rho dou E phi by dou rho minus dou E rho by dou phi is equal to minus j omega mu hz. Multiply this 1 by rho inside here. Then we can get dou E phi by dou rho minus dou E rho by rho dou phi is equal to minus j omega mu hz. Consider this as the sixth equation. So as we all know that since the wave is propagating in the z direction, for this electric field we can get the value as E phi is equal to E phi naught e power minus gamma z, because the wave is decreased with the factor e power minus gamma z. Gamma is nothing but what? Propagation constant. Okay. If we are going to differentiate with respect to the z direction, that is propagating direction, then we can get E phi naught e power minus gamma z into minus gamma, because differentiating with respect to z, right? Then we can get minus gamma into E phi. Then we can get the values dou E phi by dou z is equal to minus gamma E phi, dou E rho by dou z is equal to minus gamma E rho, dou Ez by dou z is equal to minus gamma Ez. So we are going to substitute these three values in the fourth, fifth and sixth equation. So in this fourth, fifth, sixth equations we are having the differentiation with respect to Ez. So all those components can be replaced with this values. Okay. So first here we have to consider the fourth equation. So here it is dou Ez by rho dou phi minus, actually what its value? Its value is dou E phi by dou Ez. So that value is replaced with minus gamma E phi. So minus into minus plus. So here we can get dou Ez by rho dou phi plus gamma E phi is equal to minus j omega mu h rho. So this is the updated or simplified version of fourth equation. We can consider that as a 4.a as well. So hereafter we can consider this equations alone. Okay. So the same way we can get the fifth equation. So what is the first component of this fifth equation? Its value is what? Dou E rho by dou Z. So that value is replaced with minus gamma E rho minus dou Ez by dou rho is equal to minus j omega mu h phi. Okay. So then we can get all the terms are having minus sign. So we can make it as a plus. So dou Ez by dou rho plus gamma E rho is equal to plus j omega mu h phi. Consider this as the fifth equation. Okay. That updated fifth equation. So the last sixth equation, there is no change because this equation does not have any differentiation with respect to z term. So we can keep that value as such. Next we are going to derive field components h rho, h phi, e rho and e phi. Okay, so these are the field components of circular waveguide. So first we can take this h rho and e phi component. For these two components, we have to consider the second and fourth equations, okay, for finding out h rho and e phi. So you have to remember, if you are going to find out h rho means, first we can take the second equation. From this we can get e phi value. We can substitute this e phi value to the fourth equation to get the h rho value. That is the procedure. So if you are going to find out the e phi value means, the same way we have to take the fourth equation, find out the h rho value, substitute this value in this second equation to get e phi value. Okay. So here we are going to take second equation. So here minus gamma h rho minus dou hz by dou rho is equal to j omega epsilon e phi. From this we can get the value of this E phi. Okay, so E phi is equal to what? We have to move this j omega epsilon to this side. Okay, then we can get minus gamma by j omega epsilon h rho minus 1 by j omega epsilon dou hz by dou rho. Then we have to substitute this value in the fourth equation. So what is the fourth equation here? Dou E z by rho dou phi plus gamma E phi is equal to minus j omega mu h rho. This is the fourth equation, right? So substitute this E phi value in this expression. Then we can get dou E z by rho dou phi plus gamma into E phi is minus gamma j omega epsilon h rho minus 1 by j omega epsilon dou hz by dou rho is equal to minus j omega mu h rho. Correct? So then we have to multiply this row inside this bracket. We can get the value like this. Dou E z by rho dou phi minus gamma squared by j omega epsilon h rho. Here it is minus gamma by j omega epsilon dou hz by dou rho is equal to minus j omega mu h rho. So in the next step, we are going to keep h rho in one side. For that, we can move this term to this side, okay, as a plus. So we can get plus gamma squared by j omega epsilon h rho. This value is minus j omega mu h rho is equal to the remaining terms are dou E z by rho dou phi minus gamma by j omega epsilon dou hz by dou rho. Okay, so in this one, we are going to find out h rho value. We can take it as a common one. So h rho into gamma squared by j omega epsilon minus j omega mu is equal to dou E z by rho dou phi minus gamma by j omega epsilon dou hz by dou rho. Okay, so next we have to take this j omega epsilon as a common one. So then we have to multiply this term with this j omega epsilon. Then we can get h rho into gamma squared minus j squared omega squared mu epsilon divided by j omega epsilon. So here minus j squared. Actually j squared is minus 1. So minus into minus plus. Okay. So here this term becomes gamma squared plus omega squared mu epsilon by j omega epsilon. Here gamma squared plus omega squared mu epsilon is assumed as h squared. This is very important point over here. So h squared is equal to gamma squared plus omega squared mu epsilon. Then this expression can be written like this. H rho into h squared by j omega epsilon is equal to dou E z by rho dou phi minus gamma by j omega epsilon dou hz by dou rho. Okay, in the next step, we have to move this term to this right hand side to find out the value of this h rho. Okay. So in the next step, we have to move this term to this side in a reciprocal manner. So here this h squared by j omega epsilon becomes j omega epsilon by h squared in this right hand side. So h rho is equal to j omega epsilon by h squared dou E z by rho dou phi minus j omega epsilon by h squared into gamma by j omega epsilon dou hz by dou rho. Then we can divide these two values. Okay. So finally we can get the h rho component as j omega epsilon by h squared dou E z by rho dou phi minus gamma by h squared dou hz by dou rho. So this is the seventh equation. So this is the field component h rho. The same way we are going to find out the E phi value. For that we can consider the fourth equation. From this fourth equation we can get the h rho value. Substitute this h rho value in the second equation to get E phi component. Okay. So here we can take the fourth equation, that is the updated version of the fourth equation. Dou E z by rho dou phi plus gamma E phi is equal to minus j omega mu h rho. So from this we can get the value of this h rho. H rho is equal to minus 1 by j omega mu. So this term becomes 1 by j omega mu in this side. Correct? So dou E z by rho dou phi minus gamma by j omega mu E phi. Do you all understand this one? So we are going to find out the h rho from this equation by moving this minus j omega mu to this side as 1 by j omega mu. Okay, so this is the h rho value. We are going to substitute this h rho value in the second equation. So what is the second equation here? Minus gamma h rho minus dou hz by dou rho is equal to j omega epsilon E phi. So in this one, this h rho is replaced with this value, okay. So minus gamma into minus 1 by j omega mu dou Ez by rho dou phi minus gamma by j omega mu Ez minus dou Hz by dou rho is equal to this value j omega epsilon E phi. Then we can multiply this minus gamma inside this bracket. Then we can get minus into minus plus. So here it is gamma by j omega mu dou Ez by rho dou phi. Here minus into minus plus gamma squared by j omega mu E phi minus dou Hz by dou rho is equal to j omega epsilon E phi. So what we are going to find out? We are going to find out the E phi value. For that we can keep all the E phi values in one side. So we are going to move this j omega epsilon E phi to this side. So here we can get gamma squared by j omega mu E phi. This term becomes minus here. So minus j omega epsilon E phi, that is equal to, so we have to move all other terms to the other side. So this term becomes minus, here it becomes plus. You can write dou Hz by dou rho, this term as minus gamma by j omega mu dou Ez by rho dou phi. Okay. Here we can take this E phi as a common term. So E phi into gamma squared by j omega mu minus j omega epsilon, that is equal to this value. Here we can take this j omega mu as a common one, that is taking LCM. Then this term becomes gamma squared minus j squared omega squared mu epsilon by j omega mu. As we all know that minus j squared is nothing but plus 1. Correct? So we can get the value as gamma squared plus omega squared mu epsilon in the next step. We can get the value as E phi into gamma squared plus omega squared mu epsilon by j omega mu is equal to dou Hz by dou rho minus gamma by j omega mu dou Ez by rho dou phi. So in this one, gamma squared plus omega squared mu epsilon is nothing but h squared. So here we can say E phi into h squared divided by j omega mu is equal to this value. Then we have to move this value to this side as a reciprocal one to get the value of this E phi component. So this h squared by j omega mu becomes j omega mu by h squared in this right hand side. So j omega mu by h squared dou Hz by dou rho minus gamma by j omega mu into j omega mu by h squared dou Ez by rho dou phi. So here these two values are divided. So then we can get the E phi component is equal to j omega mu by h squared dou Hz by dou rho minus gamma by h squared dou Ez by rho dou phi. So this is the E phi component. Consider this as the 8th equation. Do you all understand this one? So next we are going to find out H phi and E rho in the same way. We have to consider the first and fifth equations. Okay. So the same way we are going to find out H phi value means here we can take the first equation, find out the value of this E rho, substitute this E rho in this fifth equation to get the value of this H phi. So the same way, if we are going to find out the E rho means we have to consider the fifth equation, find out the value of this H phi, substitute this H phi value in the first equation to get E rho component. Okay. So here we are going to find out the H phi value. For that consider the first equation. So here dou Hz by rho dou phi plus gamma H phi is equal to j omega epsilon E rho. Okay. Here from this we can get the value of this E rho by moving this j omega epsilon to this side as a reciprocal one. So here it is E rho is equal to 1 by j omega epsilon dou Hz by rho dou phi plus gamma by j omega epsilon H phi. Okay, then we have to substitute this E rho value in the fifth equation. So what is the fifth equation? Dou Ez by dou rho plus gamma E rho is equal to j omega mu H phi. So this E rho value is replaced with this expression. So we can get dou Ez by dou rho plus gamma into this E rho value is what? 1 by j omega epsilon dou Hz by rho dou phi plus gamma by j omega epsilon H phi is equal to j omega mu H phi. Okay. So then we have to multiply this gamma inside this bracket. We can get the value like this. Dou Ez by dou rho plus gamma by j omega epsilon dou Hz by rho dou phi plus gamma squared by j omega epsilon h phi is equal to j omega mu h phi. Correct? So next we are going to find out the value of h phi. For that we can keep all the h phi value in the same side. Then we have to move this j omega mu h phi to this side. So it becomes minus and move all other terms to the other side. So here we can get gamma squared by j omega epsilon h phi minus j omega mu h phi is equal to these two terms become minus in the right hand side. In the next step, we can take this h phi as a common one. So here it becomes gamma squared by j omega epsilon minus j omega mu is equal to minus dou Ez by dou rho minus gamma by j omega epsilon dou Hz by rho dou phi. Then we can take this LCM. This term becomes gamma squared minus j squared omega squared mu epsilon. So this term becomes gamma squared plus omega squared mu epsilon divided by j omega epsilon. As we all know that gamma squared plus omega squared mu epsilon is nothing but h squared. Okay. Then we have to move this h squared by j omega epsilon to this side. Then we can get h phi is equal to j omega epsilon by h squared dou Ez by dou rho minus j omega epsilon by h squared into gamma by j omega epsilon dou Hz by dou phi rho. Okay, then we can cancel these two values. Then we can get the h phi component is equal to minus j omega epsilon by h squared dou Ez by dou rho minus gamma by h squared dou Hz by rho dou phi. So this is the h phi components. Okay. Finally, we are going to derive E rho component. For that, we can consider the fifth equation. From the fifth equation, we can find out the value of this h phi. Okay, what is the fifth equation? Dou Ez by dou rho plus gamma E rho is equal to j omega mu h phi. So from this, we can get the value of this h phi by moving this j omega mu to this side as 1 by j omega mu. Okay. Then h phi is equal to 1 by j omega mu dou Ez by dou rho plus gamma by j omega mu E rho. Then we have to substitute this h phi value in the first equation. So what is the first equation? Dou Hz by rho dou phi plus gamma h phi is equal to j omega epsilon E rho. So here we have to substitute this h phi value in this place. Okay. Then dou Hz by rho dou phi plus gamma into what is the value of h phi? 1 by j omega mu dou Ez by dou rho plus gamma by j omega mu E rho is equal to j omega epsilon E rho. Then we have to multiply this gamma inside this bracket. We can get a value like this. In the next step, we have to move all the E rho components in the same side. So we have to keep this value gamma squared by j omega mu E rho as such and move this value to this side as a minus 1. So minus j omega epsilon E rho is equal to these two terms become minus in the right hand side. Okay. Then we can take the 0 as a common one. Then we can take the simplification. So here it becomes gamma squared minus j squared omega squared mu epsilon by j omega mu. So here this term becomes gamma squared plus omega squared mu epsilon. As we know that this term is nothing but h squared. From this we can get the value of E rho. E rho is equal to what the value now? It is nothing but minus j omega mu by h squared dou Hz by rho dou phi minus gamma by h squared dou Ez by dou rho. Consider this as the 10th equation. So this is the E rho component value. Finally, we have derived all the field components of electromagnetic waves in circular waveguide. E rho, E phi, H rho, H phi in terms of Hz and Ez. Okay, so these four equations are very important to find out transverse electric and transverse magnetic field components in circular waveguide. So all these field components are having the second term as minus gamma by h squared. Okay, you have to remember these things.